Accounting Honors Math 2. Let's see, today is Thursday, April 2nd, and we are going to spend some time today reviewing all of the conic sections we've seen so far. Once again, thank you so much for working through things at home. Everything you're doing at home is very important, so thanks for keeping up with things. Let's see, what I'd like to start to do is, now that we know 3 of our conic sections, the circle, the parabola, and the ellipse, that's the order that we saw them as well, we're going to start to get selective. We're only working through these 3. If you are able to print this out as a review, I attached it on Canvas. That's just a little bit easier because you'll have the graphs and things. If not, you can certainly do it on loose leaf, but if you're able to print. And then your homework today is going to be these 4 problems on the back after we chat together. All right, so if you're able to print this, that would be great. What we need to start to be able to do is look at these 3 equations and start to decide, are those equations of a circle, a parabola, or an ellipse? Look at each of those equations, and over the next couple of days, that's what you need to start to decide. We started with circles, the set of all points equidistant from the center point. Which one of those equations would be of a circle? Take a moment and see if you can decide. If you look carefully at these equations, I notice a couple of things. In this first one, only the y is squared. In the second equation, x squared and y are squared. The coefficients are different. And in this third equation, x is squared, y is squared, and the coefficients are the same. Which of those would be a circle? We'll start to see that this is the equation of a circle. X is squared, y is squared, and those coefficients are the same. Actually, in this case, I have a common factor of 2, so I'm going to divide through this whole equation by 2. And I'm actually going to start with this example 3, because this is the equation of a circle. And we're going to rewrite this equation of a circle in standard form, which is x minus h squared plus y minus k squared equal to r squared. So it's a good time to stop and review all the equations we've seen so far. Divide through by 2, this becomes x squared plus y squared minus 10x plus 8y plus 32 is equal to 0. Please pause often today, and we are going to put that in standard form. Then we're going to graph this circle, and then we're going to list the important features of a circle. Well, I can remember the important features of a circle because I can see them in my standard equation. The important features of a circle are h, k, and r. So I'm going to find the center and the radius, and then sketch that circle. Pause and put that circle in standard form if you would. Okay, collect your x terms. Collect your y terms, move that 32 to the right, subtract 32. Divide by 2 and square, 25 completes my square. Divide by 2 and square, 16 completes my square. Factor this, then I get x minus 5 squared plus factor y plus 4 squared. Combine those on the right, equal to 9. Gives me the standard equation of a circle whose center is, switch the signs, 5, negative 4, and whose radius, remember that's r squared, whose radius is 3. And sketch that circle with a center of 5, negative 4, and a radius of 3. Alrighty. In order of what we learned, ladies and gentlemen, we saw parabolas next. So now I'm going to ask you to go back to example 1 and 2 and decide which one of those equations is the parabola. Pause. Okay, so by process of elimination, this first equation has only a y squared. Second equation has an x squared and a y squared with different coefficients. Which of those equations would be a parabola? This one, because it only has one squared term. So then this is my parabola. My next question is this going to be a up-down or a left-right parabola? Notice since y is squared, it's actually going to be a left-right parabola. And my vertex form is going to look like this. X is equal to, I don't know yet if it's positive or negative, 1 over 4p, because the y is squared. Y minus k squared plus h. I don't know if we've done this yet. Can you please take a moment and start to write this then in vertex form with an x equals I'm going to pause and you're going to start to rearrange this equation to start to look like this. Okay, this is pretty cool. I think it's important to jot down the standard form because I want my x on the left. I moved my y terms to the right. Y squared is positive, 6y is positive. The 1 is positive, but notice I want to complete that square. So I'm going to complete the square with y. Divide by 2 and square, I'm going to add 9. This is where it would be nice if we were together. You guys have good suggestions for me. Notice if I add 9 on the right, I have to get rid of it on the right. Remember the opposite signs when we're on the same side? So if I add 9, I'm actually going to subtract 9. And I'm going to write this as 4x is equal to factor and combine. And what is that? Y plus, divide by 2 for that term. Y plus 3 squared minus 8. Almost in vertex form, I'm going to divide through by 4, divide by 4, divide by 4, and here we are, x equals 1/4 y plus 3 squared minus 2. Alrighty, so there is the vertex form of this. Does it open left or right? Do you remember? If that leading coefficient is positive, it's a left-right opening. I call it a non-function. It's going to fail the vertical line test. Is it left or right? Right is standard. When it's positive, it's going to be a right opening parabola. Okay, let's move to the graph. And what were the important features of a parabola? The important features of the parabola, of course, the one you can see in the equation is the vertex. What is the vertex of that parabola? Remember, x goes with the x, -2. Y, k goes with the y, so that's going to be -2, -3. What were the other important features of a parabola? The other important features of a parabola were the focus and the equation of the directrix. Okay, so let's think about how we can find the focus and the equation of the directrix from that equation. Maybe I should jot that equation down here. Okay, so here's the equation of my parabola. Remember that denominator was 4p. So in this parabola, 4p is equal to that denominator, which is 4, and that implies that p is equal to 1. What was p in a parabola? P was the distance from the vertex to the focus. Since this parabola opens to the right, since the coefficient is positive, my focus is going to be 1 unit to the right of that vertex. Also, P is the distance from the vertex to the directrix. So my directrix is going to be 1 unit to the left of that vertex, and there's my vertical directrix. I'll connect those points in a second after I find a few more points on that parabola. So my focus is 1 unit to the right of the vertex. Y coordinate stays the same, move 1 coordinate to the right. My directrix, which is going to be an x equals, is 1 unit to the left of the vertex. If the vertex was at -2, the directrix is going to be at -3, and it's going to be an x equals -3 for the equation of the directrix. How do I find a few more points on that parabola? Some of us started to notice that, okay, what was a parabola? The set of all points that are equidistant from the focus and the directrix. Easiest equidistant point is that vertex right in between. I'm going to find a few other points that are, these are nice ones, 2 units from the focus, 2 units from the directrix. So that's a nice point on that parabola. I want to switch colors so you can see my parabola. So 2 units from the focus, 2 units from the directrix. There's my vertex right in between. 2 units from the focus, 2 units from the directrix. And I can connect those points to get a nice parabola opening to the right. Love it. Okay, so by process of elimination, last but not least, we saw ellipses. And this equation has an x squared and a y squared. The coefficients are different, and we'll start to recognize that as an ellipse. How do I start to write this in standard form for an ellipse? An ellipse looks like this. X minus h squared over a squared, the horizontal movement on that axis, plus y minus k squared over b squared, where b is that vertical so it's under the y, the vertical axis. And there's my standard equation of an ellipse. Pause and start to rearrange this equation. Okay, this is where I ran out of time yesterday. Sorry about that. So I want to take my time here. I collected my x terms. I collected my y terms. I moved that 5 to the right. I never complete the square with a coefficient, so now I'm going to factor and complete the square. Okay, take your time and check your work. I divided out of 4. I'm left with x squared plus 2x. What completes that square? Divide by 2 and square, I get a 1. Be careful, because I actually added 4 to the side when I distribute. So I'm going to add 4 to the right. I factored out of 3. I'm left with y squared minus 2y. Divide by 2 and square is 1. But I actually affected that left-hand side by a positive 3 when I distribute. So I'm going to balance that equation. When it's on opposite sides, I do the same thing, add 3. Factor x plus 1 squared, 4 times x plus 1 squared, plus 3 times y minus 1 squared is equal to 12. How do I get this in standard form? I need that 1 on the right-hand side. An ellipse is always equal to 1, as well as our next conic section next week. So I'm going to divide by 12 to get that equal to 1, and that also forces those denominators. X plus 1 squared over 3 plus y minus 1 squared over 4 is equal to 1, is the standard equation of that ellipse. Okay, looking at that standard equation, we're going to find the important features of an ellipse. From the equation, you can certainly find the center. The center is at, switch the signs, -1, +1. So I have a center of that ellipse at -1, +1. What else was important about an ellipse? Can you look at this equation and tell which way it's going to stretch? Is it going to be stretched more horizontally or vertically? That's the major axis. So the major axis is horizontal or vertical. Remember, this is always a squared, and this is always b squared. Since b squared is bigger, my ellipse is going to be stretched more vertically. So the major axis is vertical, and remember what lies on that major axis? The foci lie on that major axis. So now I'm going to find the ordered pairs for those foci. What distance was the foci from the center? Was that A, B, or C? A, B, or C? There's a C in the word focus, so I need to find C to find those foci. What's biggest in this ellipse? A, B, or C? A, B, or C? The largest value in this ellipse is B. So to find C, I'm going to use this version of the Pythagorean theorem, since B is the biggest. A squared plus C squared is equal to B squared. Pause and find the value of C to find the foci. Okay, we're just about there. A squared plus C squared is equal to B squared. 3 plus C squared equals 4. C squared equals 1, and C equals 1. So to find my foci, I'm going to go up 1, down 1 on that vertical axis. So let's see, from the center, if I go up, down, the x-coordinate is not going to change, but my y-coordinate is going to go up 1 to 2 and down 1 to 0. And those are the ordered pairs for my foci. I can make a nice sketch. B is 2, so I'm going to go vertically up 2, down 2 from center. What's the square root of 3? I think that's 1.7. So I'm going to go to the right and to the left of center, and I get that wee little ellipse, that oval. Alrighty, ladies and gentlemen, thanks for tuning in today. I hope you're having a good day, and try for homework tonight, and I will post the solutions. Try to recognize what each of these things are, just from the equation, why those things are what they are. An ellipse, a parabola, what are these things down here at the bottom, and if you can start to sketch those things, that would be great. Alrighty, and include the important features. And that's your homework for today. Have a good afternoon, and miss you guys. We'll talk soon. Bye-bye.